The James Webb Telescope has essentially provided the most precise image of Proxima B in history, uncovering stunning bits of knowledge into a possibly tenable exoplanet. It supports us as we embark on an excursion through space to uncover the secrets of Proxima B and find out whether it could be the next Earth. We ought to take off into the vast expanse of space, where an unidentified planet exists in the habitable zone of its star, Proxima Centauri. This planet is not just any ordinary rock discovered just 4.2 light-years away from us. There are many mysteries on this planet, and we wonder whether there is another Earth, with seas and life blossoming on its surface. Anyway, wait, there's more. Proxima Centauri B isn't alone in that system. It orbits around the red dwarf star, along with another body, Proxima Centauri C. And who knows what other mysteries the star system holds. Maybe there's another companion that we haven't yet discovered. The secret continues. Proxima Centauri B receives roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface, and perhaps even life? As we explore beyond our own solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, there are countless opportunities for exoplanets. Some exoplanets even have no bounds, untethered to any star, like wandering space travelers. Among them all, Proxima Centauri B stands out as an especially striking and captivating planet. It has a year that lasts only 112 Earth days and a distance from its star that is typically closer than Earth's to the Sun. One side of the planet is constantly washed in sunlight, while the opposing side remains in eternal darkness. Now let's examine Proxima Centauri, the star around which Proxima B revolves. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Rigil Kentaurus, also known as Alpha Centauri A, and Alpha Centauri B. These stars combine to form the closest star system to our solar system. Alpha Centauri A and B form a binary system and appear as one star in the constellation Centaurus. They are the third brightest stars in our night sky. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star, an M-type star, found 21 light-years from the other two stars, typically about 4 times the distance between Earth and the Sun. It is the closest star to us. In fact, Proxima means closest in Latin. It was discovered in 1915 by Robert Thorburn, an astronomer from Scotland. Despite being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. But don't let that fool you. Red dwarfs like Proxima Centauri are still a fascinating star class. They may not produce a lot of energy, but the internal convection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, indicating frequent and intense explosions. As a low-mass star, its habitable zone would be much closer than the Sun's, projected somewhere in the 0.23 to 54 cents range. But it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, stronger than the radiation we get from our Sun. It's so extreme that even the lightest particles of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is in the right position or distance from its star doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and keeping a surface that is water-friendly. Without it, living creatures would be vulnerable to harsh space weather, making life nearly impossible. So while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain cautious, as there are many factors that render it inhospitable. The mission to reveal the truth about Proxima B continues. One tool that has garnered astronomers' attention is the James Webb Telescope. After many years of anticipation, the telescope was finally launched in 2018 and will help us determine if there is life on Proxima B. However, as with everything in science, things are never as clear as they seem. Several adjustments were needed to ensure the James Webb Telescope delivers accurate images. As Abby Taber, a Harvard theoretical physicist, demonstrates, whether a planet like Proxima B can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or a planet with an atmosphere. But what if the planet has an environment that makes life hard? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus, with a dense atmosphere significantly thicker than Earth's and temperatures that make it extremely inhospitable. The journey to unravel the mysteries of Proxima B is not without its difficulties. But the James Webb Telescope offers hope. There are additional costs and challenges to consider. Space scientists feel the need to observe planets like Proxima B. There's a lot on the line. But the rewards are even greater. The opportunity to explore the unknown, to uncover the secrets of a distant planet that may possess life-sustaining potential. It's a pursuit worth chasing. If the exoplanet were habitable, might we one day visit it? It's the closest exoplanet to us, which makes it so captivating, almost like exploring our own backyard. Even more exciting is that it's roughly the same size and position in relation to its star as Earth is to the Sun. The habitable zone suggests that it might have life-sustaining conditions. Proxima B's proximity also makes it an ideal target in our quest for life beyond Earth. With it being so close, it's a prime candidate for interstellar missions. Think about exploring this Earth-like exoplanet. Although we can't go there yet, it's definitely on the radar for future missions. As technology advances, it's one of the most exciting endeavors in the field of space exploration. On the other hand, reaching it is not an easy task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Still, it's an option. Solar sails have been proposed for these missions. The use of extremely thin sails could propel a spacecraft bound for Alpha Centauri and Proxima. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. Here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima B. However, like any ambitious endeavor, there are limitations. For instance, the presence of an atmosphere does not always guarantee life. Proxima B could be like Venus, with a thick, hot atmosphere that is unwelcoming. Additionally, the James Webb Telescope can detect such emissions if they reach a brightness of only 5% of the planet's daytime side. That may not seem like much, but when dealing with a star. Neptunian giants are also found there, exoplanets which are similar in size to Neptune but can vary dramatically in atmosphere and temperature. Some are icy and distant, while others orbit perilously close to their stars, becoming hot, volatile worlds with violent winds and deep, pressurized atmospheres. But amid this cosmic diversity, it's the Earth-like rocky exoplanets, like Proxima B, that stir the imagination most. These are the ones that could, just maybe, hold life. The possibility of oceans, clouds, rainfall, and perhaps even biological signatures such as methane or oxygen. This is what astronomers yearn to discover. With the James Webb Space Telescope pushing the boundaries of observation, we're entering a new age of detection. Not only can it capture faint infrared signals from distant planets, but it may also one day be able to detect biosignatures, clues that life might exist or may have once existed on these worlds. Imagine this. A future mission confirms water vapor in Proxima B's atmosphere. Then traces of oxygen. Perhaps even a puzzling chemical imbalance, something that can't be explained by geological activity alone. Suddenly, the question shifts from could there be life, to what kind of life? And are we alone? Begins to feel like a question with an answer within reach. Proxima B becomes not just a point of light in the night sky, but a destination. A symbol of possibility. With emerging propulsion concepts, like antimatter engines, fusion drives, or laser-powered light sails, interstellar travel, once a staple of science fiction, begins to peek over the horizon of feasibility. But for now, we observe. We listen. We gather data and prepare. The journey to Proxima B may be long and filled with unknowns, but one thing is certain. The human spirit, ever curious, is already halfway there. The stars are calling. And Proxima B, quiet and mysterious, might just be waiting for us to answer. These include Uranus and Neptune, as well as the small and hot Neptunes, both of which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being difficult to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths of this size, which have masses more than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets, Proxima Centauri B, was recently discovered. It orbits the star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. Although it is close to its host star, it is still far enough away to be considered in the zone of habitability. Proxima Centauri B is not the only one with a companion. Proxima Centauri SE is much further away from the star and has an orbital period of about 5 Earth years. In 2020, it was discovered using pre-recovery Hubble data. Even more interesting about Proxima Centauri is that it appears to be an incredibly bright world, possibly due to the existence of a ring system. This adds more to discover within the system of Proxima Centauri. Astronomers noticed a change in 2019 in the star's orbital speed, which could be the result of another planetary companion. If confirmed, this planet will be called Proxima Centauri D and will be roughly the size of Mercury or Mars. Imagine a life where the night sky is brimming with stars and countless different planets, each with its own distinct characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them. With new discoveries being made constantly, it's an exciting time to be a space scientist. While we don't yet have an accurate count of them, we do know that exoplanets exist in abundance, just as we know the stars that light up the universe. However, exoplanets are not without their challenges. They are often hidden by the glare of their host stars, making them difficult to study. Still, with advancements in technology, direct imaging of exoplanets is now possible. For a direct image of an exoplanet, it needs to be big enough to be seen by the telescope, far enough from its host star so as not to be obscured, and young enough to be hot and visible from Earth. These requirements restrict the number of exoplanets that can be seen directly, but they provide a fascinating glimpse into the attributes and composition of these distant worlds. Exoplanets are most commonly found through the changes they induce in their host stars. A planet's gravitational pull can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope utilized the transit technique, which measures a star's light dimming when an exoplanet passes in front of it. This method has provided valuable information about the size, distance, and temperature of exoplanets. Here are a few amusing facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets, like those in our solar system, can also have natural satellites known as exomoons. With more than 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets remain to be discovered. The James Webb Space Telescope, JWST, from NASA is unveiling the secrets of the universe, one discovery at a time. This extraordinary telescope has been gathering information and taking stunning images of the universe, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that may change our understanding of the cosmos forever. NASA announced that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides crucial insights into the planet's composition and formation, offering us a glimpse into the mysteries of the universe. This gas giant planet, located 700 light-years away around a sun-like star, signifies a major step forward in the search for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery would give us a new perspective on the universe, one we've never seen before, sparking excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has also been busy taking stunning photographs and collecting data about the universe. The young, infrared-emitting object number 1104 illuminates the cool, wispy cloud material, while orange spots behind the cloud reveal light from distant stars obscured by the ice in the cloud. This remarkable research is part of Webb's Ice Age project, which aims to study the formation of ice, from its creation to the development of icy comets. Additionally, JWST has imaged the inner workings of a dusty disk in the vicinity of a red dwarf star, capturing it for the first time at these infrared light frequencies. Proxima B is an intriguing exoplanet that has captured the attention of astronomers and scientists alike. The discovery of this Earth-like planet, just 4.2 light-years away, orbiting within the habitable zone of Proxima Centauri, has opened exciting opportunities for future exploration and study. As we continue to examine planets like Proxima B, the capabilities of advanced telescopes like the James Webb Space Telescope, JWST, are becoming ever more crucial in unlocking the mysteries of distant worlds. JWST's ability to detect infrared light allows it to gather information about surface conditions and atmospheric composition of possible exoplanets like Proxima B, offering insight into whether these planets could support life or harbor oceans and other vital ecosystems. As researchers push the boundaries of space exploration, one thing becomes increasingly clear: we are only at the beginning of understanding the vast diversity of planetary systems in our galaxy. Each new exoplanet discovery challenges our assumptions and expands our knowledge of how planets form, evolve, and interact with their environments. Take, for example, rogue planets, mysterious worlds that drift through the galaxy without orbiting any star. These free-floating planets may have been ejected from their original systems or formed independently in the cold void of interstellar space. Although difficult to detect, their existence suggests that planetary systems are dynamic and often chaotic. Meanwhile, astronomers are developing even more sensitive instruments to detect the faintest signals from distant worlds. Missions like the European Space Agency's Plato and NASA's upcoming Nancy Grace Roman Space Telescope are expected to uncover thousands of new exoplanets, some potentially Earth-like, in the coming decades. These missions will help refine our estimates of how common habitable planets truly are. At the same time, scientists are working tirelessly to improve our understanding of planetary atmospheres. By studying the light that passes through or reflects off an exoplanet's atmosphere, astronomers can determine its chemical makeup. Molecules such as oxygen, methane, and water vapor, especially when found together, could hint at the presence of life. Yet, the search for life is not limited to looking for Earth-like conditions. Astrobiologists are also considering exotic forms of life that could survive in environments vastly different from our own, such as beneath the ice of Europa, within the clouds of Venus, or on worlds bathed in the light of a red dwarf star. These efforts are driven by one of the oldest and most profound questions in science: are we alone in the universe? Each discovery, no matter how small, brings us one step closer to an answer. And while we have yet to find definitive proof of extraterrestrial life, the data we are gathering is more promising than ever before. As we look to the future, collaboration between international space agencies, universities, and private companies will play a critical role in shaping the next chapter of space exploration. With artificial intelligence aiding in data analysis and telescopes peering deeper into the cosmos, the pace of discovery is accelerating. In the not-so-distant future, we may witness the first robotic missions to exoplanets or even receive signs of intelligent life beyond Earth. For now, we continue to gaze at the stars, filled with wonder, curiosity, and an unyielding desire to explore the unknown.